Ceramics are such a wonderful materials, smart materials, which happen to study the influence and behavior of load on structures. So this is part of structural health monitoring. The structural health monitoring is defined as acquiring, validating, and analyzing technical data to facilitate life cycle management decisions. So we can appreciate the application of structural health monitoring everywhere in this world. There are many methods of structural health monitoring. If I start from the traditional methods like visual inspection method, I have to say something about visual inspection method. Especially when there are structures which are exceptionally large, big structures, they require huge computational impulse type of forces, and the output will be just like the other speaker said, like displacement, strains, velocities, or acceleration can be measured. But the problem with such a low frequency method is that it cannot locate the position of damage. See, we can always say there is some damage in the structure using this method, but the problem is how to locate it. We really don't know where is the damage. Everyone say that structure could be damaged, but the problem with this method is it fails in identifying the damage. And there is one more method like statistical structural response technique, which is on the similar lines, which works on the similar lines. The only difference between these two methods is one employs low frequency technique, this employs static load technique. Static force is applied as input and output again the displacement strains. The problem with such a method is large loads are required to obtain measurable deflection. So if we want to measure some deflection, unfortunately we need to apply large loads. Thus this method is again, I can say, is troublesome, costly, requires huge machinery, and sometimes we may have to construct a secondary structure over the existing structure. The problem with this method is it requires skilled manpower and it is highly uneconomical. Yeah. Now we come to my topic, smart material based high frequency vibration technique. This is also one of these structural monitoring methods. The only difference is it employs smart materials which are capable of not only identifying that there could be some possible damage in the structure, but also can locate the damage, which is one of the essential features of today's health monitoring. So there are, as I said, there are many structural health monitoring. I can start from PCT, piezoceramic transducers to fiber optics. There are many. In fact, yesterday in the postal session, I saw many smart materials. Now, as I said, like the beauty of these methods, smart material based methods, are they're highly automated and highly economical, requires less time consuming compared to previous methods. I don't mean other previous methods are not good. The person just now he spoke about vibration techniques. They are also good methods, but like for example, he said that those can be used for debonding things. But the problem with this is like on large scale, other methods may fail. On the large scale application, this is the best method. Yeah, as I said, these are the methods of structural health monitoring, but we go with I presume PCT based high frequency vibration. It works on one principle known as electromechanical impedance principle. The principle says if a PCT is either embedded inside a structure or surface bonded, and when it is subjected to electric field, results in activation. The PCT vibrates in all the direction, all possible direction. So what happens? The structure tries to resist the people till today have used positive signature conductance, but they ignored B. I would like to show some of the results there, which shows B is also useful. Now for this, we considered uh, some specimens made of aluminium. We used PCT both as sensor and activator. Just like in other the other researcher just now said that he used PCT as sensors and some PCTs as actuators. But in our case, we used PCT both as sensor and actuator. That means we activate and as well as measure the both for activation and measurement. So you can see what happens like in this case before loading. I mean like before loading case and after loading case, you can see the difference in activation of PCB. The PCB a lot, but additionally you can also see rotation of the signatures. You can see the rotation of the signature. To further exemplify that, to say that susceptance could be better alternate or can give better results, we did some more experiments. The boundary condition here we used was simply supported. And this is the PCT, and this is the structure. We totally took nine combinations. So it's like 1A, 2A, 3A. So we had total 9 conductance and